Welcome to my stream. Welcome back to our crafting interpreters streams. Let's see. Let me switch over before I forget. Okay, I think we're up and running. So yesterday we were playing around with the scanner, trying to get this to work in Rust. It looks like, yeah, the way I left it off, there's a whole bunch of variants that we're not handling yet because we haven't finished writing the scanner. But at least everything compiles, and it does panic, and I need to figure out why. And I think it's because I wasn't doing the bounds checking correctly on the args. Hello, Dayloop. Good to see you. Isn't Toggle? Oh, I thought Toggle was streaming. He must have just stopped. Yeah, so I think what's happening is here I just need to check. So args len, if it's 1, that means we have the argument. If it's 2, it must be coming through here. Yeah, maybe this needs to be a 2 as well. Maybe that was the problem. Yeah, so it's doing a run prompt right now, which is good and bad. Because I'm not seeing the prompt. Where's the prompt? Let's take a look. Oh, you know what? I bet the problem is here is we're just not flushing the standard out. So let's figure out how to do that in Rust. Rust flush standard out. It looks like I've looked this up before. Okay. Pum pum pum. Pum pum pum. Standard out dot flush. Okay, so let's add that. I don't need the thread part of it. Let's move the standard stuff up to the top where it belongs. And then we're going to just add write and standard out here. And then right after the print, we can just do the flush, right? You don't have to allocate anything. You can just say standard out flush like that. Okay, let's see if that runs. Yeah, so okay, now we have a prompt. It doesn't do anything because we must have failed something else. We're supposed to be passing this into the parser, right? Should be calling run. And run should call scanner scan tokens, which right now I think is just a dummy. All right, let's get this working before we go back to the scanner. Oh, I see. Okay, yeah. So maybe we are calling the scanner, but we just have an infinite loop because we never change self current, right? So this is starts at 0. It's always less than the source length. And so we're looping here scan token, which is doing nothing. Okay, good. I think we're back to a working piece of code now. So we just finished this last time. Dayloop says press Control D after entering something in the prompt. I'm worried about losing my window, but I'll give it a shot. Control D, yeah, yeah. I think we're hitting the infinite loop. All right, so in scanner. Sorry, my voice seems to be raspier than normal. We're going to modify scan token to change this stuff here. So we're going to call advance and then call add token for each one of these guys. Okay, so down here we say let C equals self advance. And switch C. Oh, so what am I doing? Match C. I was trying to copy this stuff. If it's a open paren, then we're going to say self add token. Token type, right? Left paren. I think that's what I called it. Yeah. So there we go. Token type, left paren, right paren, and all those guys. Okay, and then how many of these we have? Right paren, left brace, right brace, comma, dot, minus, plus, semicolon, and star. Okay. Let's change all these guys. Comma, dot, minus plus semicolon and star. Who did that? Sika07. Sika07. Thank you for the follow. Let's see. So we did this. Now we need to write advance and add token. Yeah. Sorry, I should have read this. In each turn of the loop, we scan a single token. This is the real heart of the scanner. We'll start simple. Imagine if every lexeme were only a single character long. All you would need to do is consume the next character and pick a token type for it. Several lexemes are only a single character in lock, so let's start with those. So we did those. So again, we need a couple of helper methods. So let us write a couple of helper methods. This doesn't need to be public, right? This is a private function. And I think isAttend is also private. Okay. So I have advance. Oh, okay. So we have a thing now. We need a mutable reference to current, which means all of this needs to be mutable. Scan token needs to be mutable. And that means this is mutable advance, not self. And this says, oh, and it returns a char. We have the tokens here from the string. I think we can just say get, right? And unwrap. Self, source, get, current. Except there's no auto increment. Result is equal to this, and then we say self current plus equals 1. And then I'm going to just dummy out add token just for now, just to see if this is correct. Oh, self current. Oh, yeah, that's associated function, not a method, and we're going to have to make that mutable as well. String indices are ranges of view size. Oh. A source is a string. Should we just convert it to a vector of chars? Oops. Less than. Thank you. And then during the initializer, we can just do that here, right? We can say source chars collect. Oh, and I forgot to return the result. I went through all that work and then I ignored it. Okay. Expected char. Oh, but found an option. So we can unwrap. And char is a copy type, so that should work. Oh yeah, and then we'd have, okay, and then Java you don't have to worry about matching all the patterns, but we can just do panic here. Panic unmatched token type. Just for now, I imagine this will change. I just want to get this to, okay, so we've got 49 warnings, but this is all so far correct. All right, so add token is pretty straightforward. If we add token of a token type, we just call add token type null. All right, so here's where we run into a small problem with Rust. There's unreachable day loop reminds me. Thank you. I keep forgetting about that. So, you know, Java is polymorphic, right? Across function arguments, whereas Rust is not. I can't have two different methods in here called add token. So I'll have to create it. Well, just make up a new name. That's not a problem. Self add token object. Since we're passing in an object here, and this is an object literal. So now I have to go back to my objects. Where did I put the objects? Was it in token? I should separate this out into its own file. We do have a nil, and this is passing a null. Oh, we want an option null, right? That's what we put in the token, was an option object. Okay, which in Rust speak, it's not null, it's a none. So this will be t-type. I can't put type by itself, but I can say t-type and then none. Oops. And then add token object, self type token type, and then literal is going to be option object. Okay, so string text is source substring start current. Okay. So here's where we run into another little problem. We want to pull out the substring from this source. Can I do from a vec? I can do a range, right? Self source get. Can I do this? Oops. Rust vec get slice. Is there a get slice? Oh, you can just do it this way. Okay. So why don't I do that? And then I forget what the arguments were. Start to current. So self start to self current. That's not inclusive. Hopefully this is also not inclusive. We'll find out. Tokens. Oh yeah, that's good because we increment current right after we get the character. So this is going to be one after the character we got. So that should work. Self tokens push token. We have type, text, literal, and line. What the hell's line? Oh, line is part of the object, the struct itself. All right. So we have t-type is. Let's pull up that file token. Yeah, it's t-type, lexeme, which is the string. Let's call this lexeme. Sharpburger 91 says there's also vec as slice, but that would take the entire vec. Oh, would it own it? Is that what you mean? And then we would lose access to it. Literal, and then self line. Right. So I think that's this line. Except these are all not public, which probably means I can't do this. I probably have to create a token new or call token new. Why don't I do that? Like that. All right, let's see if this works. Sharper Guy says it wouldn't own it. It just means that you would get all indices rather than just the ones you're interested in. Oh, I see what you're saying. Okay. Okay, this says expected struct string down slice char. To string? Can I do that? Method cannot be called on char due to unsatisfied trait bound. So we have a slice of chars, which is, can I call collect on it maybe? I have no idea. Nope. So what was the trait bound that was failing here? Display. Doesn't exist for this. All right, so how do we convert a vec of chars to string? Oh, can we do string from? Nope. Doesn't have a size known at compile time. Ampersand. From slice of chars is not implemented for. Okay. Rust string from slice of chars. Can't without some allocation. Oh, okay. Convert it to an iterator. And then I hit F1 and this thing pops up. Teki-chan, hello. All right, so iter collect. Nope, still doesn't like it. Oh, I put a reference there. There we go, okay. Teki-chan says, how are you today? I'm great. How are you doing? All right, so I just learned something here. That's the whole point of, oh, Dark Reader. I was gonna check that out, wasn't I? I forgot to do that. So I just learned something here. We can convert a slice of chars into an iterator and then collect those into a string. All right, so then we did this. That means this is all supposed to be working now. The advanced method consumes the next character in the source file and returns it. Where advanced is for input, add token is for output. It grabs the text of the current lexeme and creates a new token for it. We'll use the other overload to handle tokens with literal values soon. Oh yeah, okay, so it's this guy. And we just have to rename it slightly. There's no reason to overload there, right? So before we get too far in, let's take a moment to think about errors at the lexical level. What happens if a user throws a source file containing some characters LOX doesn't use, like @ hashtag caret at our interpreter? Right now, those characters get silently discarded. Well, not in my version. They aren't used by the LOX language, but that doesn't mean the interpreter can pretend they aren't there. Instead, we report an error. Okay. So we're going to generate an error, unexpected character. Now, we had an issue before with errors. Right, and what we ended up doing was deciding we were going to just throw or return a LOX error. So everything should have a, whenever we have an error, we should pass back a LOX error, which means scan tokens returns a LOX error, and scan token should as well. So let's put a question mark there. This should be a result of nothing or LOX error. And then this ends up being okay. And this says we're going to return, and we have an error method here. Yeah, so we just say LOX error self line, right? And then unexpected character. String. Oh. Yep, that's right. That's wrong. Okay. Oh, I have to make it an error. Oops. Type. Is that right? Yeah, okay. So that's the equivalent here. So now we get unexpected character. Note that the erroneous character is still consumed by the earlier call to advance. That's important so we don't get stuck in an infinite loop. Note that we also keep scanning. There may be other errors later in the program. It gives our users a better experience if we detect as many of those as possible in one go. Otherwise, they see one tiny error and fix it, only to have the next error appear, and so on. Syntax error whack-a-mole is no fun. All right. So here's where we have an issue, right? Because what we're going to do is we're going to return this error, and this little question mark says to return it here. What we actually want to do is continue, right? So instead of doing it this way, because what they were saying, so we want to keep scanning. So we don't want to abort the entire process of scanning. So the one way to do that is to, okay, instead of just returning this, what we can just do is call report, right? Error. Yeah, we can report the error here. So we can say match self scan. I hate this keyboard. Okay, match self scan token. If it's okay, we do nothing. if it's an error, then we're going to report it, e.report, and then we keep scanning. Right? Supplied 0 arguments. Oh, and then we're just going to pass in toString. Right. Okay. So we should be able to run this now and see it'll consume these guys. And if we pass in something that's not one of those, then it should give us an error, right? So I cargo run. If I say open paren, it says Lexeme here. Oh, but we're not getting the prompt again. But it's still prompt. It's still reading. Okay, so there's a bug in my loop. So this is interesting. So I'm now able to tokenize this stuff. If I do the @ sign, which shouldn't exist, we do get the unexpected character error on line 1. Well, this is line 3 really, but we should be able to do that, right? Yeah, and then we just get a whole bunch of those guys. And, you know, plus, minus, star. Oh, but they're all being matched as left paren. That's not good. Oh, yeah, I never fixed those. Okay. First, let me fix the prompt thing. The prompt should be inside. Oh. Yeah. So this is break. This does the run. And so before we continue, I guess we can just put it here. And that should give us our prompt. I don't like having it in 2 spots, but this is the way we did this. We can clean it up later. All right, so the other thing I need to fix is a scanner, because everything is getting left paren. So we got to fix all of these guys. This is left brace and right brace. Comma dot minus plus semicolon. I think I put it like that, and then star. All right, so now if we cargo run, we should be able to do a whole bunch of different little things here. There's plus, minus, semicolon, star. Sure. All right, left paren, right paren, plus, minus, semicolon, star, UF. And we are getting the lexeme. Right, so we're getting the actual characters and sticking it in there, and all the literals are saying none, which is good. Okay. CM says left parens everywhere. Yep. And not a drop to drink. All right. Don't worry, since had error gets set, we'll never try to execute any of the code, even though we keep going and scan the rest of it. Okay, so that was the other thing we kind of glossed over yesterday, was setting a global flag called had error, because Rust and globals are awkward. What we want to do is be able to, if we have an error, save the error. Mod had error. Let's call it an option. Locks error. None. And then if we have an error, we'll just save the last error, whatever that was. And then here we'll say if let sum e is equal to had error, then we're going to return else this. And that way we can actually return an error. Oh yeah, sum e. Right, so we're just returning the fact that we have had an error, and we'll just return the last error. And in main, we don't need to report it. We just don't want to run it. Error was already reported. Oh, this is in run down here. Oh, all right. So scan tokens returns the error, which comes up here, which is going to already be reported. So do that. Okay, that's good. Okay, so operators. We have single character lexemes working, but that doesn't cover all of blocks as operators. What about bang? That's a single character, right? Sometimes yes, but if the very next character is an equal sign, we should instead create a bang equals lexeme. Note that the bang and equals are not two independent operators, so you can't write bang space equals in locks and have it behave like an inequality operator. That's why we need to scan bang equals as a single lexeme. Likewise, less than, greater than, and equals can all be followed by equals to create the other equality and comparison operators. For all of these, we need to look at the second character. All right, so let's go back to our scanner. All right, and then we're going to do here bang. And then we have this match function we're calling. Okay, private Boolean match. Okay, so how are we going to do? Oh, we can't call it match either, can we? Because that's a keyword. What are we going to call it then? Match talk? So this will be self add token. And then we're going to steal the if to do this. I guess match talk of equal. Then we're going to say token type bang equal, else token type bang. Will that work? Mizzard says is match. Okay, yep, I like that. Okay, so let's see if this will work. Let's throw in the is match function here. Is match. This does not need to be a. Oh, it does. Because we need to check things here. Okay, so it doesn't have to be mutable, but it doesn't. Oh, it does have to be mutable. We do increment current. Huh. Okay. And then expected char, and it returns a bool. So we say if self is at end, then false. Else if I'm trying to shoehorn Rust's return semantics in here. Else if self source get self current is not equal to expected, and I have to put a star in front of that, right? And unwrap it. Then also we're going to return false. Else we're going to say self current plus equals 1 and return true. Okay, so I think what's going on here, right, is we're checking to see if we're at the end before we try to read the next. I said GT instead of get. Before we try to return the next. Rust can be a little bit smarter, right? Because we can just say get, and then if it's not none, then check to see if it's expected. Right? I think we can write this maybe like this. If let sum ch is equal to self source get self current, return ch is equal to expected. Oh, we have to say let self current plus equals 1, and then otherwise return false. I think I think that's this, right? Well, let's give it a shot. I mean, this is, I think, a more rusty way to do it than this. And that's what we're trying to do, is port this to Rust and make it rusty. And then advanced, we probably should do something similar. Let's see if this this checks. Of course it doesn't check. What did I do wrong? Match arm body without braces. Really? Oh. I put a semicolon there. That's what I did wrong. No implementation for ampersand. Okay, so we just star that, right? Cannot borrow self as mutable more than one at a time. Okay. So we can't quite do it this way, but we can separate it out, right? So now we need the braces. Let talk equal this, right? And then right, that's what we're looking at here. And then let's do it this way so everything lines up. And then here we're going to just say self add token talk. Yeah, okay, that worked. That's unfortunate we can't do it that way, but it makes sense, right? Because if you know, we can't borrow mutable here and borrow while we're borrowing mutable there. Although this technically does return before this gets called, so technically, I guess it should be okay. But that just means we're going to have, this is all going to be complicated. Mizard says, can't you format it automatically in visual mode with the equals key? I don't know if I have that set up. Let's find out. If I do this, oh, let's not do the whole thing. If I do that, and then, yes, how about that? I can do that. Thanks, Mizard. I just learned something new. Hello, Supercuber. How you doing? All right. So we've done this. So we just need to do the remaining 3. Supercuber says, I wanted to say that you inspired me to go through this book myself. I'm actually quite far in. Oh, excellent. Are you also porting it to Rust, or are you following their language of choice here? Java. Let's see. So we want to do basically the same logic 3 more times, right? Let's copy all of these lines here and then just say 1, 2, 3, and we change this to equals, change this to less than, and change this to greater than. Okay, so you answered yep, which means you're doing both languages at the same time? Oh, you're calling it RLOX. Oh, neat. Okay. Ooh, so this will be cheating for me, right? If I look here, that'll be spoilers. So I'm not going to look at your code just yet. But that's cool you've got that there. You're on chapter 8 already. You must have spent a lot of time on it then, because I get 2 hours in the morning to do this, so I'm going to be going a lot slower than you. But yeah, I'll keep this in the back of my mind here that you've got this, but I'm going to close it down for now because I don't want spoilers. All right, so we have equal, which I think we just called equal, right? Because we renamed them slightly. And then this one is called assign. And then we have less equal, and then less. And actually I can just say this, oops, greater, equal, and greater. Perfect. Okay, so those should all compile, yes? Nope. Equals with an S, got it. There we go. Okay, we're down to 31 warnings. Nice. All right. It's like a conditional advance. So this is the match method, although we called it isMatch. Okay, Supercuber, I have to ask, what did you call your match function? It's like a conditional advance. We only consume the current character if it's what we're looking for. Using match, we recognize these lexemes in 2 stages. When we reach, for example, bang, we jump to its switch case. That means we know that lexeme starts with bang, and then we look at the next character to determine if we're on a bang equals or merely a bang. I called it matches. Okay, yeah, that works. I like that. Okay, longer lexemes. We're still missing our one operator / for division. That character needs a little special handling because comments begin with a /2. Yeah, so in C, comments get handled by the preprocessor, which is its own little mini language, right? And they get stripped out before the C compiler even sees anything. Supercuber says, by the way, you can call it r#match. I think that's a forwards compatibility feature. Really? Well, I mean, Vim is not complaining. It looks kind of ugly though, so I'm not going to leave it. Oh, but yeah, and Vim doesn't like, it's not highlighting this as a function call. Yeah, it went right through it. So, okay. That's an interesting feature. Let's call it a feature. I'm not going to do that though. All right, so how are we going to handle /? Let's go back up here. For this, we're going to say if self is match / then a comment goes until the end of the line. While peak, oh, now we have a peak function, is not equal to new line, and not self is at end self advance, else self add token type / oops, like that. All right, so all we need now is peak. Supercuber says, yeah, you're supposed to use it when new keywords get introduced and you have a clash. Oh, that makes sense. Yeah, that makes sense. So you just do a search and replace on your code base and get rid of all the... Did we check to see if this works? Or am I just barreling on regardless? Does this... oh, this won't compile because I don't have peak. Let me... I forgot to... I don't remember if I checked to see if this new match case works. So let's do this. Comment that out. We don't need the peak. Cargo run. So I should be able to do this. And it still works. Left paren, right paren, left paren, right paren. We now have bang equals. Yep. Equals should be equals. One equals should be a sign. If I say that, left paren assign. Ooh. Okay, we have a bug. That is not a thing. What's the bug, though? It looks like, oh, yeah, okay, so that's the bug. isMatch should only increment if ch is equal to expected. Ah, that's the bug. Okay. I'm glad I checked. Let result equal this. And then we can say if result self current plus equals 1, and then just return result. This seems a little awkward though, doesn't it? get rid of this because we could always recreate that. Oh, else, false. Now it's even more awkward. I don't like this code anymore. It was nicer before, but wrong. And nicer when it was wrong. That's pretty bad. Wizard says match self sort if some ch. Okay. But we got to set. We have to return true or false if. Okay, so this is what Wizard is suggesting. Right. Oops, got the space. Match that if some. Oh, I see. You're putting what's it called, a barrier there? Expected. Self current plus equals 1. Return true. I guess we can just say true. And then anything else is just false. Oh, I forgot the arrow. I'm staring at it. Okay, that's a lot rustier, isn't it? Thank you, Wizard. That's very nice of you to suggest that and get me past my mental block here. All right, so this reads pretty easily. If the current character is some, and it matches the expected, then we'll increment and return true. Otherwise, in any other case, we will return false and not do the increment. Okay, so let's see if that fixes that bug. It does. Excellent. Okay. And then we have comments. Let's just... Oh, right. I didn't finish that part. Let's work on the scanner code here. Okay. Oh, so now we have to write peak. So this is similar to the other two character operators, except that when we find a second slash, we don't end the token yet. Supercuber says, by the way, something that you might skip. Right now, you're not handling UTF-8 correctly because you're using byte offsets. Might want to add UTF support later with chars and all that. So what I did, I'm kind of cheating. I am converting all of my source from a string that we read into chars first. And then I'm indexing into the chars array to get all of my lexemes. So this is probably avoiding some of that UTF-8 complication by just doing this kind of cheating method. This is something we added at the beginning of the stream. Supercreeper says that's why .get worked. Yeah, this works. Okay, excellent. So we're on the same page. That makes me happy. Peak. And it returns... We don't need a mutable reference, right? This is not doing any changes, but it is returning a char. So keep consuming characters until we reach the end of the line. This is our general strategy for handling longer lexemes. After we detect the beginning of one, we shunt over to some lexeme-specific code that keeps eating characters until it sees the end. So this is our other helper. Okay, so we're going to try again. If let sum ret equals self source get self current. Okay, we're going to return null if we're at the end. Else. But doesn't that mean we're going to need to check that Yeah, while self peak is not equal to new line and is not at the end. Oh, okay. So it will end up being at the end after we get to, advance. So this will be true, even though we return a null here. That's fine. It's sort of like advance, but it doesn't consume the character. This is called look ahead. Since it only looks at the current unconsumed character, we have one character of look ahead. The smaller the number is, generally the faster the scanner runs. The rules of the lexical grammar dictate how much look ahead we need. Fortunately, most languages in wide use peak only one or two characters ahead. Technically, match is doing look ahead too. Advance and peak are the fundamental operators, and match combines them. Superkeeper says, my peak returned an option, and then is at end was implemented in terms of it. Oh, okay. That would be a lot more rusty, wouldn't it? Yeah. And actually, having peak return an option would reduce this to a single line. Right? It avoids the null hack, Superkeeper says. Yeah. Should we do that? Is some? Oh, we don't want to do that. We actually want to take a look at it. So how would the while loop go? We can say loop if let sum x is equal to self peak, called ch. If ch is not equal to new line, self advance. It's a little longer. Sharper Guy says there's also while let. Oh, I did not know that. But you can't do this, right? You have to say if ch is not equal to n advance. Else break. Because once we hit the new line, then we want to break. We want to advance past that, don't we? How does this code look? While peak is not equal to new line. I guess that's fair because even if we leave the new line in the stream, the scan stream, we're going to ignore it because it's white space. We haven't gotten to that part of the code yet, but I'm sure we're going to get there at some point. White space gets ignored. All right, so this is a little longer, but this is a lot shorter. So let's see, does this check? I forgot to close the delimiter here. Which one? On this guy. Okay. Yeah, okay, so here's the match, here's the else. I just need a close on here. And oops. Oh. Yeah, this is returning an option reference, char reference. So we'd have to do this and then summon. But only if it worked. So it's not as clean. Superkeeper says, I remember when Rust didn't hint you which one was the unclosed. Yeah, then you have to go hunting it down. Because if I unwrap this, then now it's no longer a sum. And if I put a star here, oops, stop that. That's going to dereference the option instead of dereferencing the char inside the option. Supercomputer says use cloned, and there is copied you can use on an option. Wow. Okay, so I'm learning. You know what? Here's the problem now. I'm learning way too many things. I'm going to forget half the things I learned. So you guys are. Wow. Okay, so that's cool. So, and if you have an option that's got a reference inside it, this is interesting. So option char. If x is option char, then x.copied becomes option char. Wow. Sharper Guy says that is the essence of Rust. It all makes sense, but there's just so much to learn. Yeah. But the more I do it, right, the more it's going to get ingrained in my muscle memory. So this is cool. I really like this. Sam Zire says works with iterators too. That's okay. Okay, you're starting to break my brain, guys. It'll all get in there at some point. All right, so we did peak, right? Sort of like advanced. We talked about that. Comments are lexemes, but they aren't meaningful, and the parser doesn't want to deal with them. So when we reach the end of a comment, we don't call add token. When we loop back around to the start of the next theme, gets reset, and the comment's lexeme disappears in a puff of smoke. Okay, so this should check. We should be able to now cargo run and create a comment. So if I say open paren, close paren, / this is a comment, we get line 1 unexpected character. Oh, it's a space. Yeah, we can't do spaces. This is a comment. Nice, look at that. It saw the open paren, close paren, and ignored that. But if I say unit divided by brace, we get unit divided by brace. Okay. This is good. This is good. It only took me an hour to get through. Here's where the scroll bar is now. And I think I started right around here. So we're doing well. Let me mute just for a sec. I'm going to take a sip of water, so I don't want you guys to hear me swallowing on stream. Hang on. All right. I'm back. All right, so while we're at it, now is a good time to skip over those other meaningless characters, new lines, and white space. Okay, good. I was hoping we'd get here. This is getting very long, this scanner. Okay, so we have space, or carriage return, or new line. All get ignored. Oh, tab. But new line actually changes the code here. We're going to say self line plus equals 1. All right. So now line gets incremented. I should see errors cargo run. If I do this and then hit at, oh, it still says line 1. Oh, you know why? Because we're creating a new scanner each time. But now I should be able to hit spaces in here, and then this is a comment. Yeah, okay. Yeah, because we're starting a brand new scanner each time, so we're never going to see this line change. It will only happen if I'm able to put in multiple lines at the same time, which currently I cannot. Oh, you know what we can do though? Let's create a file. So I should be able to do this and then say this and then put an @ sign there. So on line 3, it should give us an error, right? twice. It gives us 2 unexpected characters. That's probably a bug we need to figure out. Yeah, Supercuber, I'm ahead of you. If only I implemented run file. I did. That was one of the first things we did yesterday. But I never tested it until just now. Oh, this is why we're seeing it twice, because we're reporting it here. We can say ignore error was already reported. I'm glad you said that, because I wouldn't have looked to show it to you to see what the error was. So if we run this, yeah, so now we get just line 3, unexpected character. Okay, very good. This is moving right along here. When encountering white space, we simply go back to the beginning of the scan loop. This starts a new lexeme after the white space character. For new lines, we do the same thing, but we also increment the line counter. This is why we used peek to find a new line ending a comment instead of match. Ah, okay. We want that new line to get us here so we can update line. Our scanner is getting smarter. It can handle fairly freeform code like this. This is what I'm putting my test now. Nice. Okay. String literals. Now that we're comfortable with longer lexemes, we're ready to tackle literals. We'll do strings first, since they always begin with a specific character, equal quote. Okay, so the code itself is pretty straightforward, or at least in the scan loop here. Let's say case. Oh, case. What am I doing? So we can just say here self string, right? We don't need to put a break statement, and then this calls this private function. Oh, interesting. They're saying to put where to put it. I don't think it really matters where we put it. I can put it after scan token, sure. String what self, and it returns nothing. That makes it convenient. While. Oh, right. Now we have to do the same here, right, as this line. Right? If ch. So this is calling peek twice. This is interesting. And we don't actually need to do that if we have the character coming out this way, right? If it's equal to a new line, then self line plus equals 1. And if it isn't, we just ignore it. Self advance. So how are we building the string then? If is at end. Oh. So we do need to do this. Results locks error. Supercuber says need to stop at equals as well. Oh. Thank you. So I can say match ch. If it's quote. I said equals again, didn't I? If it's a double quote, then we want to break. If it's a new line, then we increment line. And in either case, we advance. I don't know why I just did Control D, because we're in the middle of writing code here. It should consume the closing. So I was thinking, well, why don't we just put advance up here? Will that work? Yeah, because we're going to consume this. We're going to consume the new line. This says while it's not equal to double quote and is at end, then go in advance. Oh, here's where we consume the closing new line. Okay, I gotcha. Right, so now we're going to have to say error, return, error, locks, error, new? I forgot how I do it now. Where is it? Error, it's just locks error, error. And we're going to give it the line number, self line, and we're going to say unterminated string. Like that. And here's where we consume the closing quote. And then trim the surrounding quote. String value is the source substring start +1 current -1. Okay. So how did we do it last time? We just did self-source like that. So let value equals self-source self-start +1 through to self-current -1 iter collect. And I think I do need to tell it to string so collect knows what to do. Maybe? I don't know. And then self add, token object. And this time, instead of passing in none, oops, stop that. We're going to pass in a string, token type string, and the value is going to be some value. Oh, it's an object. We have to say some object string value. That's kind of ugly. Forgot that guy. ToString. Oh, you know what I should do is put the ToString inside the error thing. Really? Oh, I called it str. Okay. I guess I was trying to avoid the overusing string. And then, well, we definitely have to return an OK here. Okay. There we go, that worked. But now we're ignoring out of string here, right? String has to have this question mark guy there so that it bubbles up the results. Why didn't Rust complain about this not being handled? Right? If I do this, doesn't Rust usually complain? Maybe it's just a warning? Cargo run. Yeah, result may be an error variant which should be handled. Okay, so let me put the question mark there. Cargo run. So now we should be able to create a string. Look at that. So the lexeme includes the quotes, but the token does not. Right, because that's because we started here and ended here. And we added 1 to the start and subtracted 1 from the but we should also be able to put it inside and make sure things continue to parse. So we have less than some string. All right, so not less than. Open paren, string, close paren. Okay. So this is working. This is exciting stuff. Like with comments, we consume characters until we hit the quote that ends the string. We also gracefully handle running out of input before the string is closed and report an error for that. Unclosed. Unterminated string. Look at that. It worked. I was one step ahead of you, Supercuber. I just saw your comment now. It's rare that I'm any steps ahead of anybody. For no particular reason, lock supports multi-line string. So I think this is working because, let's take a look at the code. Actually, I have to tell it to edit the code. So we're going to peek. If it's a quote, then we're going to break. We come down here. If we're at the end, then we're not at the end because we still have this quote here. We advance past the quote, and then because now current is on the quote symbol, we subtract 1 from current here. If we hit a new line, we'll increment line. It looks like we can have multi-line strings, and we'll advance. Yeah, so multi-line strings work there. If this returns none, right? Self is at end is going to be true, and then we'll do the unterminated string logic. Okay, so that works. For no particular reason, Lock supports multi-line strings. There are pros and cons to that, but prohibiting them was a little more complex than allowing them, so I left them in. Okay, fair enough. That does mean we also need to update line when we hit a new line inside of a string. Finally, the last interesting bit is that when we create the token, we also produce the actual string value that will be used later by the interpreter. Here, that conversion only requires a substring to strip off the surrounding quotes. If Lock supported escape sequences like \n, we'd unescape those here. All right, so I'll just add a comment here. To do handle escape sequences. Okay. Number literals. All numbers in locks are floating point at runtime, but both integer and decimal literals are supported. A number literal is a series of digits optionally followed by a dot and one or more trailing digits. Since we only look for a digit to start a number, it means -123 is not a number literal. Instead, -123 is an expression that applies negative to a number literal 123. In practice, the result is the same, though it has one interesting edge case. If we were to add a method calls on numbers considered -123.abs, this prints -123 because negation has a lower precedence than method calls. We could fix that by making negative part of the number literal, but then consider var n equals 123, print -n abs. This still produces -123, so now the language seems inconsistent. No matter what you do, some case ends up weird. I would argue that this is fine because negative does apply to has lower precedence than the abs call. Whereas here, the natural way to read this would be as a single number. So maybe that's something we can fiddle with, but that would change the semantics of the language, so I don't know. We don't allow a leading or trailing decimal point, so both of these are invalid, .1234 or 1234 dot. We could easily support the former, but I left it out to keep things simple. The latter gets weird if we ever want to allow methods on numbers like 123.squirt. To reduce the beginning of a number like seam, to recognize the beginning of a number like seam, we look for any digit. It's kind of tedious to add cases for every decimal digit, so we'll stuff it in the default case instead. I understand that the tedium in Java, but it's not tedium in Rust. So I'm gonna do the Rust thing. That's is digit right there. I guess we could also, yeah, I mean that works. I was trying to think, should we use the built-in libraries is digit, but no, I'll just do this. So this is just self number, and I bet you this is going to also return an error possibly. Right, so that goes there, and this relies on this little utility, is digit. Oh, I see, okay. All right, you know what, we're going to stick with this. Although that might come back to bite me, right? Maybe there's other places we'll need is digit, like right here. Okay. Maybe we can use a match here as well. So self number. This thing, put it after scan token. let's put it right here. Number .self, and it returns a result of either OK or LOX error. There we go. So while isDigit peak advance. While let sum ch equals self peak. Match ch in 0 ... equals 9. I'm trying to think. How do we want to do this? Self advance. Continue. This is kind of awkward, right? And then break. Sure. If peak is a dot or is a digit, so now we say if let sum ch equals self peak, match ch dot or 0, 9, and then we have something called peak next. Oh, okay. All right. I'm going to give up. And I'm going to write the isDigit. I'll put it right here. Does it need peak next needs it, but isDigit does not need it. Need to be a so we can just say char bool ch is greater than equal to 0 and ch less than equal to 9. Done. So now we can just say we'll do the same thing here. If it's a dot and then the next one is advanced, is digit. Peak next. Then advance. And then we want to while isDigit peak advance. Yeah, this is getting awkward to write, isn't it? Scanner isDigit ph advance else. Okay. Misery says there is the built-in char is ASCII digit. Okay. Right. Self-advance and continue. I'm not fond of that. I'm not fond of this either. But that works. And then let's use that is ASCII digit thing. Peak next should return the char, right? Is peak next is going to return an option. Can overload, you can shadow ch, right? If ch is ASCII digit, then advance. This can be if equals dot. Like that. Right, because this is just a single advance, and then this this will do a while, and we can just say ch is ASCII digit. Let's see, does that check? Oh, self advance. And we haven't written peak yet, next yet. Okay. And then at the end of all of this, we'll say self add token, token type, number. Oh, and then we have to parse out this. Okay. Supercooper says maybe isDigit can take an option and give you false when none. That's not a bad idea. That's not a bad idea at all. Option char. If ch is sum. Oh no, if let sum ch equals ch. Ch is greater than equal to, oh, we can just say ch is as digit, else none. Oh, false. Lovely Mono says he could have used the isDigit function of C standard library. Extern great libc. Yeah, you know what? So the reason, so Java also has a built-in, is it a digit thing? So I think they're just the author of this thing wants to just make everything self-contained. Although we are using vectors and lists, and we're not writing all of those things. Oh, 2001. Thank you for the follow. Yeah, why don't we do this, and then we can do this part here, right? We can then say, how can we do this? We can say while we could say while scanner is digit self peak, right? Self advance. Right? That's all we have to do there. Supercooper says it kind of makes sense, gives you a good spot to add hexadecimal support, for example. And Lovely Mona says, then use isXDigit. All right. Yeah, I got about a half hour left. I don't think I'm pretty close. I'm looking at where the scroll bar is by wiggling the window here. We might get there, but I got to fix up this number thing here. Okay, so with this cleans up this code here, right? So we can now say, we say if it's a dot and it's a digit. So that's what we're doing here. We can say if self peak next scanner is digit self peak next. Advance, right? So that cleans that up, and then we can say here the same thing. Scanner is digit advance. Right, so this is this part here. Oh, no. Not quite. This while loop has to be inside. Okay. And then we add token type number, and now we have to parse the number. So we need to pull it out as a string. Let value string equals, and it's going to be the same as the string line. Oh, except without the quotes, right? Which means we don't have to do this part or this part. We're going to collect it into a string, and then we want to convert it into a number. What did I use? A token. I used F64s. Okay, so we just say F64 is equal to value dot parse, and then object num. Now tell me what I did wrong. Oh, peek next doesn't exist. Let's do a quick peek next. I guess it has to return something. Option char and none. Okay, so I can't do this. Expected. Oh, I have to unwrap it. Oh, add token object. Supercuber says instead of if let and then compare, you can compare it to some dot. I can do this like that, and then I can put an and here. Like that. It liked it. Son. Ah. Okay. And then we just have to do an okay here, right? Is there a unwrap? I guess. What does parse return if it can't? It can't parse. It's a result type, but what's the result type? It's just some random result. What I want to do is return a locks error if we failed to parse the thing. Because right now, what this does, right? What do we do in Java? I think this is just going to throw an exception. So we can do something similar. Supercuber says, check the docs. You bastard. All right. I'll check the docs. Java double parse. Yeah, so it throws a number format exception. Okay. But also digits will probably always parse. Yeah, okay. Fair enough. Then we don't need to actually return anything here. And if we do that, right, it should always parse, and we don't have to worry about the question mark down here either. Okay. And then we have to write peek next. Brainsman, thank you for the follow. You know, when the zombie apocalypse comes, you might want to change your name. They'll go after you first, man. All right, so let's go over to scanner and then write peek next. Where's peek next? I put it somewhere. I should put it close to peek, right? Put it right here. All right, so peek next is going to return an option char. If current plus 1 is greater than source length, return null. Right, so all we have to do is, we're going to peek next. So all we're going to do is current plus 1. All right, so self, source, get, self, current plus 1. Copied. Done. Wow, that was easy. Finally, we convert the lexeme to its numeric value. That's what we're doing all the way up here. Oh, right. Okay. We consume as many digits as we find for the integer part of the literal. Then we look for the fractional part, which is decimal point. That's this line, this bit here, followed by at least one digit. So if it's a dot followed by one digit, we'll advance past the dot, right? We do have a fractional part. Again, we consume as many digits as we can find. So while it's a digit, so we do the same loop. Looking past the decimal point requires a second character of look ahead, since we don't want to consume the dot until we're sure there's a digit after it. So we add this. I could have made peek take a parameter for the number of characters ahead to look instead of defining two functions, but that would allow arbitrarily for our look ahead. Providing these two functions makes it clearer to a reader of the code that our scanner looks ahead at most two characters. All right. Lovely Mona says geeks for geeks. All right. Finally, we convert the lexeme to its numeric value. Our interpreter uses Java's double type to represent numbers, so we produce a value of that type. All right. We're using F64 right there. We could implement that ourselves, but honestly, unless you're trying to cram for an upcoming programming interview, it's not worth your time. Dusty Puzzy says, hey, Uncle, so you done with RLTK? No, I'm not. Thank you for asking, though. We finished, last week we finished, Town Portals. We got through all of that, and I actually got it working over here, so we can get, we have a Town Portal scroll now. See? And if I hit Shift 3, it'll pop me back to town, and it puts a little heart where the Town Portal is. And then I can go right back to where I was, being killed by a kobold. And I'm taking, so I'm going to be alternating, doing RLTK and then other programming stuff. And right now we're working on crafting interpreters. Dusty Pussy says you're fighting burnout. Yes, I am definitely fighting burnout. I don't want to burn out on the RLTK stuff because I'm really enjoying that and I want to take it nice and slow. But this is also interesting stuff too. So writing my own Rust from scratch. Well, actually, I shouldn't say that because I'm getting a lot of help from chat. Writing Rust using pair programming is a lot. I'm learning a lot more by doing this than going through the RLTK stuff. But I do want to get back to RLTK, and I'll do that next week. And then eventually write my own roguelike. That's the idea. That's the ultimate idea. Okay, remaining literals are booleans and nil, but we'll handle those as keywords, which gets us to Barney Trades. Thank you for the follow. All right, reserved words and identifiers. Our scanner is almost done. Yes. Yeah, there's the scroll bar. Okay. The only remaining pieces of the lexical grammar to implement are identifiers and their close cousins, the reserved words. You might think we could match keywords like or in the same way we handle multiple character operators like less than equal to. Case O, match R, add token or. Consider what would happen if a user named a variable orchid. The scanner would see the first two letters or and immediately emit an or keyword token. This gets us to an important principle called maximal munch. When two lexical grammar rules can both match a chunk of code that the scanner is looking at, whichever one matches the most characters wins. Bright22B, thank you for the follow. Consider this nasty bit of C code, minus, minus, minus A. Is that valid? Depends on how the scanner splits the lexemes. What if the scanner sees it like this, as negative minus minus A? Then it could be parsed. But that would require the scanner to know about the grammatical structure of the surrounding code, which entangles things more than we want. Instead, the maximal munch rule says it always scanned like minus minus negative A. It scans it that way even though doing so leads to a syntax error later in the parser. That is true. Bear Duda, hi. Lovely Mona says, that fragment seems so needless. Just parse identifiers and check if they're keywords. Yeah, although, you know, back in the olden days, when I wrote BASIC, you did not need to put spaces around keywords because it did, I guess, whatever the opposite of maximal munch is. Minimal munch? So yeah, there's arguments for both ways, I guess. So that rule states that if we can match ORCID as an identifier and OR as a keyword, then the former wins. This is also why we tacitly assumed previously that less than or equal to should be scanned as a single less than equal to token and not less than followed by equal. Maximal munch means, sounds like a breakfast cereal, doesn't it? Means that we can't easily detect a reserved word until we've reached the end of what might instead be an identifier. After all, a reserved word is an identifier, it's just one that has been claimed by the language for its own use. That's where the term reserved word comes from. So we begin by assuming any lexeme starting with a letter or underscore is an identifier. All right, so is alpha. So this is where we actually have to go into the default, I guess, after all. You know what we can do is we can do this, right? What the hell is our character? It's just C. And we can put a guard on this. C is, oh boy, rust, char, methods. Is ASCII alphabetic. Like that. Superkeeper says, I actually decided on my own whim that false, true, nil should be literals, but you should just follow what they do unless you want to fix bugs where your logic diverges. Yes, okay. Yeah, I'm just going to follow along here, and then we can always refactor later. We'll just call self-identifier. Right, I think ASCII alphabetic is just, you know, uppercase, lowercase. Yeah. Yeah, okay, that works for me. Let's go along with that. And now we're going to write an identifier. And again, they're saying put it after a scan token. Well, I guess it puts it right here. So while. And now how do we write this? Scanner is alphanumeric. Oh, they put a they put the thing there. Okay, well, just follow along. Self peak advance, and then we're going to say self add token identifier. I mean, this seems really simple, right? And we just need to write is alphanumeric. Oh, they're splitting it up into is alpha and is alphanumeric. Or, I forgot about the underscore, right? C equals underscore. Like that. Because I don't think ASCII alphabetic includes the underscore. Unless there's like an identifier. No. All right, we'll just leave it like that. That looks good. So is digit. Let's put is alphabetic. The is alpha thing over here. Char is ASCII alphanumeric. Yeah, but we don't want to start. We don't want to start with, right, a number. If it's a number, we want to do the number thing. Yeah. Okay, so now we're going to say fn is alpha, which is going to take an option char and return a bool. And then we say if let sum ch equals ch, and we're going to say return ch. Okay, so oh yeah. So here we can do it, Mizu. Yep, you're right. You were ahead of me, weren't you? Is ASCII. Oh no, this is just ASCII alphabetic too, right? It's alphanumeric is digit. Oh. Okay, we'll put the alphanumeric in here. Because this is actually should just be is alpha. Let me do this and we'll see what happens. If we need an alpha on its own, then we can do that. Otherwise, we'll just do it this way. So does this check? It does not, because I did that. And then what's wrong here? Oh. This function doesn't have a self. Duh. And it needs to be mutable because advance is in there. Okay. Oh, and I put a semi there. Should not. Supercuber says, by the way, for some reason I actually ran into 2 internal Clippy errors while... Really? You found bugs in Clippy? You know, I haven't done any Clippy yet, so we'll do that at the end as soon as this is over. Although I only have 10 minutes left. I'm running out of time. I'm hoping that we can finish this up. Oh, good. Yes, we're almost done because we're up to the challenges, which I'm not going to do today. Or I'm not going to look at anyway. So this gets identifiers working. So let's see if we can do identifiers. Cargo run. Foo. Type identifier. Lexeme is foo, literal is none. Perfect. Okay, so now we're going to do here, to handle keywords, we see if the identifier's lexeme is one of the reserved words. If so, we use a token type specific to that keyword. We define a set of reserved words in a map. And this is just in a static. Wonderful. Okay, so now we have to figure this out. I guess in this scanner, when we create the scanner, we can do this. Yeah, I wish we had static stuff in. What are we just calling this? Keywords. And it's going to be from string to token type. New. And then here, oh, we can just create it here, right? Let mut keywords equals hash map new, and we'll just say keywords insert, and we're going to say and gets token type and, right? And then we'll do it for class else false. Oops. This way. Class else false for fun if nil or print return super this true var while. Lovely Mono says, if only Rust had better compile time features so it could have hash map at compile time. But hash map is heap allocated, Supercuber says. Does it need to be a map? Could you instead have a method? That's a good question. That's a good question. Because all we're going to do is look to see, right, if it's a keyword. We could just call is keyword. But it needs to return the type. So why don't we try it that way? It could just be a giant match statement, right? And then keyword. And we'll just, it doesn't need to take in anything other than the string, right? Check string, and it returns an option of a token type. So we should just say match check. Actually, we want to do str, right? So we can just put the keywords right here and quote and returns token type and then anything else is going to return none. Oh, some. Right? And then in the identifier, we have it says replace one line with all of these lines. So our string is going to be the same as this guy. And this is called text in the code here. And let token type is equal to scanner keyword of text. And we can just say if let some token, I'm trying to hurry now just to finish this up, and I'm making more mistakes. Then we can just say self add token identifier, else self add token t-type. Oh, I got this backwards. Right, and then we can just return none. Oops, what doesn't it like? Oh, keywords. Yeah, I'll just call it keyword. Expected to. There. There's probably a better way to do that. Okay, so now we just need to add all these guys. Class else false for fun if nil or print return super this true var while. All right. So we go here. That's and already class. Oh, you know what I'll do is just to save some typing. False for, and then I'll capitalize those in a second. Fun if nil or print. True bar and while. All right, so now I just need to look for colon colon and then say 3 tilde. Yes. Good. It looks kind of ugly with all this raggedy stuff, but if I try to line it up, cargo format's going to unline it up for me. All right, so if we use that keyword's token type, after we scan an identifier, we check to see if it matches, and if so, we use that keyword's token type. Otherwise, it's a regular user-defined identifier. And with that, we now have a complete scanner for the entire lexical grammar. Fire up the REPL and type in some valid and invalid code. Cargo run. While this is valid, have some fun. All right, so while gets the while, this gets a this, we get a bunch of identifiers, and we have fun, and then the EOF. So I think this is working. What does Clippy have to say for itself? Oh boy. Yeah, I'm not worried about these things yet because I'm sure we're going to get to those in a bit. Although, did I miss this? Variant is never constructed. Oh, unreachable pattern. All right, let's fix this first. What line was that on? 122. Wait, did I? Oh, I did the guard wrong. Right? That's better. And then we still have these unconstructed. Yeah, this token type nil right there. Was it saying that it's not being constructed? Oh yeah, so we could just change this to if let okay. Yeah. Error. I guess it doesn't matter, right? Yeah, if let error something equals run buff, then we want to exit like that. Okay. Maybe keyword is never used. I think, but we are getting the keywords, right? Yeah, it's called right here. Maybe the problem was that other guard thing. Let's see. Oh, run buff is error. Okay. That's even better. And we can do the same thing down here. Oh, we don't actually do anything with anything. So we can just ignore it. Now we have an error. What did I mess up? This? Yeah, okay. What else, Clippy? What else you got for me? Are we getting... No, we still have 11 warnings. We're not getting any... Oh, this needs to have a result, which we can ignore also, right? Let's clean those guys up. Flush. It's kind of an ugly way to clean it up, but it works. And then what are the other things? Help change this to a stir. Okay. And then we have this if chain can be rewritten with a match. Oh, yeah, that's a good point. Match args when. If it's 2, then we do this. If it's 1, then we run prompt. And otherwise, we print a usage. Right? We still have 8 warnings. Okay, we're not using this. That's fair enough. We're not using those guys. We're not using those guys. Nil, true, false, and field has never read line usize. But I'm pretty sure we're reading it, right? Because we were printing out. Oh, in the token, yeah. So in the scanner, we're using the line, but in the token, right? The scanner's lines get printed if there's an error, but the token's lines don't. These confuse me because nil, true, and false do get. Here's true right here. That gets constructed. Here's nil. Let me clean up the other things though. In standard main, we're not using file, buff reader, or read. And in scanner, we're not using hash map anymore. Right. Okay. I'm going to leave these alone because I don't understand why they're there yet. I'm sure it'll come to me. Here's token type nil. Here's token type true. Oh! These are in... Oh, right. These are these guys here. And yes, we're not creating these. Okay. All right. I was getting a little confused, wasn't I? Yeah, it's... My stream has been too long now. Okay. Nedax, thank you for the follow. You followed just in time for me to commit this and push it up to GitHub. We don't need the test thing anymore. Get add source, git commit, gem finished scanner code. There we go, git push. And take a quick look here. There it is. Okay. So we're good. All right, thanks everyone for hanging out with me, and let's see who's streaming. So this person here, Rustaway, was streaming for a few days, and I hopped on their stream a couple of times, but either they have no mic or they have no speakers or not paying attention to chat. It was kind of odd. Migrations with Reshape, a neat Rust tool. Okay, Rust Reshape. I don't know what reshaping is. Migrations with Reshape. Let's try that. An easy to use zero downtime schema migration tool for Postgres. Does that sound interesting? NetX says, why not use Rust Analyzer? I actually am using Rust Analyzer. When I start NVim or NeoVim, it kicks up a Rust Analyzer in the background. I just don't have it so that it's doing tab completion and all that kind of stuff, because that gets in my way. I don't get along with things that are covering up parts of my code as I'm typing, or complaining that as I'm typing, right? I haven't finished writing the line yet, but it's already complaining that there's syntax errors and things like that. But I do use it for, I mean, it is running in the background, so it is doing code checking when I save. All right, so why don't we let's see if chiropractal is. See how they're doing. I probably should not be doing this on stream directly, right? I get to show you guys an ad. I don't want to show you guys an ad. That's annoying, right? We'll see how they're doing, and if they're looking for chat, then we can just raid them. All right. Yeah, they are active in chat, so let's go raid them. Thanks everyone for hanging out with me. I really appreciate it, and I hope you had a good time. I certainly did, and I will. I'll see you tomorrow with more of this this lock support to Rust. Thanks again.